Today's lesson is about how to run a good experiment and how to collect and organize data from it. Let's say you're a researcher and your boss asked you to design an experiment. A good experiment design would contain these three things. It would be representative of the entire population you're trying to create a conclusion about. Your sample of things or people that you're using to make the prediction on the pattern would be completely random. And your sample should be large enough to provide accurate data. Determine whether the following is a good design for an experiment and why. So for each of these following examples, our job is to check to see whether the sample they describe represents the entire population, is selected at random, and is large enough to provide accurate data. So let's read the first one together. 100 people in Lafayette, Colorado were asked to eat a bowl of oatmeal every day for a month to see whether eating a healthy breakfast daily could help reduce cholesterol. After 30 days, 98 of those in the sample had lower cholesterol. Is this a good sample? Yes, this is a good sample because it's random and large enough to represent the entire population. Question 2. 200 students at a school basketball game are surveyed to find the school student's favorite sport. So here we're trying to study the favorite sport of the entire school population, and we're doing that by surveying 200 students at the school basketball game. Now 200, that's large enough to provide accurate data, but the sample isn't random and it doesn't represent the entire population. It's focusing on the population, part of the population that we know already likes basketball. So it would be biased. Everyone would say basketball their favorite sport and would ignore all the students who are attending other sports games instead. So no, this isn't random. It's taken the school basketball game, there's a bias. Try the next couple questions on your own. Go ahead and check your answers. For number 3, every other person leaving a supermarket, that's pretty random. There's no bias in that. Asked to name their favorite soap, and that would add up to be a lot of people. So yeah, that's random enough and large enough to cover the whole population. For the next one, if you're only asking 4 people out of 500, that's definitely not a large enough sample size to represent the whole population and to get a good read on what's the norm for the seniors. For the last one, 600 randomly chosen pea seeds. 600 should be large enough, and it specifically states they're randomly chosen, so yes, that'd be large enough and random enough to represent the entire population. So now you know how to choose a sample for your experiment so that it's random and large enough to represent the entire population. Now we're going to talk about how to sort the data you get from an experiment in a way that's easy to analyze. A common technique to sort data is to use a frequency table or a cumulative frequency table, which is really the same thing with one extra column at the end. So for our first question, here we have a study that followed a soccer team and kept track of how many goals they made each game. So let's figure out how many number of goals we should have here for the different options in our chart. So the smallest number in our list of goals scored per game is 0, so we'd start at 0, and the largest number is 5, so we'd count up to 5. Go ahead and fill in that left column of your chart. Now we're going to tally mark to represent each game. So for the first game, the team scored 2 goals. So we would find the 2 row and tally mark by that and cross off 2 in our original list so we know we're done with recording that one. For the second game, they scored 0 goals, so you put a tally mark by the 0 and cross that out. For the third game, they scored 5 goals. The next game after that, 3 goals. Game after that, 1 goal. And the game after that, 0 goals. Go ahead and continue filling out the tally marks for all the rest of the study and all the different games they played. Go ahead and check your answer. Now that you have the tally column done, you're going to fill in the frequency column. That's really just translating the tally marks into numbers. So here, 0 goals, there's 3, so we write 3. Go ahead and fill in the frequency column. Translate the tally marks into numbers. And check your answers. Now let's talk about what the cumulative frequency column means. Cumulative means everything added up. So what you do here is for the first one, you just write whatever the frequency was. 3, you just copy that over here. And then for every row after that, you take the old answer and you add in the number next to it. So cumulative frequency here in this part of the chart really means the number of goals that were 1 or less than 1. In other words, this row plus all the rows above it. So the frequency of the 1 goals was 3, the frequency of the 0 goals was 3, so just take the frequency of the 0 goals, add the 3 here, you get a cumulative frequency of 6. And then you take that, and that's 6, and you add the frequency of the getting 2 goals, of 5, and you get 11 here. Keep following that pattern, fill out the rest of the cumulative frequency chart. Eleven plus 2 gets you 13. 13 plus 3 gets you 16. 16 plus 2 gets you 18. Now, one thing you might want to always double check when you're done with your chart is one way to make sure you really remember to look at everything in your original chart is see how for this original chart each row had 1, 2, 3, 4, 5, 6 different numbers, and there were 3 rows, so there'd be 18 different numbers here. Your cumulative frequency should match that, 18, because it's adding up the frequencies of all the different numbers you had in the original chart. So looking at that chart, we're going to use that to analyze our data. What number of goals was scored most frequently? If you look at that, the goals that had the most count was the 2 goal games. How many more times did the soccer team score 2 goals than 4 goals? All right, so let's look at how many times they scored 2 goals and how many times they scored 4 goals. They scored 2 goals for 5 games, and they scored 4 goals for 3 games. 5 minus 3, 2 more games that they scored 2 goals than 4 goals. Now, sometimes in your experimental study, the numbers you get and the results are far enough apart where you don't really want to create single number sections. Like here, the smallest number is 38 in our study and the largest number is 57. So we really wouldn't want to have a chart that goes 38, 39, 40, 41, 42 because there wouldn't be enough space to go all the way to 57. So when that happens, you want to group your numbers somehow. Common ways of doing that is to count by fives or to count by tens. Here we're going to count by fives. If the smaller number is 38 and we're counting by fives, let's start at 35. So 35, 36, 37, 38, 39, that's 5 numbers, and then that's one section. Next section, 40, 41, 42, 43, 44. That's 5 numbers, that's another section. Notice how the front of each section is starting with really counting by fives, 35, 40, 45, 50, 55, and then it's just going to the number right below that. 39 is right below 40, 44 is right below 45, and so on. All right, from here, your job is to fill out the rest of the chart on your own. Pause the video until you're done. Go ahead and check your chart. Remember, once you have the tallies and the frequencies figured out, cumulative frequency, you start by saying, well, cumulatively, between 35 through 39, there was really just this frequency 2 that it's next to, and then you just add the frequency of each row below it. So if you want the cumulative frequency for 44 and everything above it, you just do 2 plus 6. If you want the cumulative frequency for 59 and everything above 59 in the chart, you just take the previous cumulative frequency and add 1 here, and so on. How many states have temperatures below 49? So here's where cumulative frequency becomes really useful. If they want to know the number of states have temperatures below 49 degrees, that really means everything in this sections. Remember, the word cumulative really just means as a group, everything in a group. So if we want the group of how many states had a temperature between 35 through 49, really the easiest way to do that is to look at your cumulative frequency. If you really wanted to, you could just re-add up the 3 frequencies that fall in the range that are 49 degrees or below. But that would take a little bit more time. Great job today, guys. Don't forget to turn in a picture of your notes on Schoology.